We would like to know how our solar system got here, and by extension, how the Earth got to be the way it is, with us on it. We'd also like to understand how other solar systems got here and how similar our solar system is to those other solar systems. One important factor in this is figuring out what are the planets in our solar system made of, and also figuring out what are forming solar systems made out of, things like debris disks or protoplanetary disks. So the way that I focus on understanding what planets are made of is something called infrared spectroscopy, and this is just looking at how light at different wavelengths in the infrared is reflected and emitted from the surface of planets and from dust within protoplanetary disks. For this project, I'm measuring a very important number for understanding how light interacts with planetary surfaces and the dust in both our solar system and in exosystems, called index of refraction. And this explains how light is bent by the material at different wavelengths, kind of like a prism. So the way I measure this quantity is I take a powder of a meteorite, and then the other thing that I'm looking at in this project is a powder of an organic analog. And analog materials are very important because meteorite samples and things like that are fairly precious. So sometimes we want to use minerals and other materials that we make in the lab in order to study extraterrestrial materials. And I put this powder in the infrared spectrometer and I measure its response at different wavelengths, and then I use that to derive the index of refraction. If you're interested in taking a deeper look at this, you can come to my poster at AGU. I'm Jessica Arnold, a planetary scientist at Carnegie DTM.